Welcome. This tutorial is a brief overview of how to use Wax and Jekyll to build minimal digital projects. My name is Angela Zoss, and I'm happy to share this work done with my colleagues Joe Klein and Wilkinson Saldaña. I would also like to take a moment to acknowledge that my home institution, Duke University, gathers on land that has long served as the site of meeting and exchange amongst a number of indigenous peoples, historically the Shakori and Catawba people. Our focus on minimal digital projects today is part of a longer story of librarians and researchers building digital projects collaboratively. Over the years, how we collaborate on digital projects has changed, from hand-coded HTML websites to services built on platforms like WordPress.com to projects spun up from locally hosted instances of software like Omeka. We've built up an ecosystem of mature open-source platforms to support this work. As you can see here, many common platforms actually have their roots in projects begun a decade or more earlier. In the mid-2010s, a community of developers in libraries emerged that grappled with ethos of building and maintaining. In this essay, Alex Gill proposed minimal computing as a way to tackle this critical question. What do we actually need in our digital projects? What would it look like to collaboratively build in a way that emphasizes precisely the architectures of necessity? Minimal computing emerged as a nexus for digital scholarship practitioners in libraries. It proposed a path forward by utilizing minimal computing principles. Minimal computing provides a conceptual framework for building. It emphasizes creating sustainable projects by minimizing choices like software dependencies that propagate maintenance tasks in the future that eat up labor and resources. We found the assertion of maximum ephemerality especially useful when thinking about a repository. Instead of imagining a repository as an eternal vault of content, quote, what if we make our collected materials extremely easy to access and build off of? What if we design with the eventual end of our project in mind? End quote. If we take those goals to heart, we end up making very different decisions about how to build, use, and contribute to open source platforms. Wax provided the key piece of software to make this all possible. In 2018, the Minicomp team released Wax as, quote, a minimal computing project for producing digital exhibitions focused on longevity, low costs, and flexibility, end quote. Wax provides the foundation for a wide variety of minimal projects with a focus on digital exhibitions and image-driven digital exhibitions in particular. One great example of how Wax can be used and extended is the Proposals project from the Monument Lab. This project shares the results of a participatory research project to explore monuments in Philadelphia. The project uses Wax to explore almost 4,500 proposals for new monuments, including a large thumbnail gallery and an interactive map of proposed monument locations. Now we'd like to share a bit more about how Wax works. To understand Wax, it's important to start with a look at Jekyll. Jekyll is an open-source website builder written in Ruby. Jekyll takes plain text files you write in simple formats like Markdown and compiles them into a full website. Jekyll has built-in concepts for several very common website features, including pages and posts. Importantly for digital exhibits, though, Jekyll also makes it easy to create collections. Jekyll collections are custom-defined groups of objects with shared metadata fields and relationships to other objects. For example, if you're using Jekyll to build a website that sells merchandise, you might have a single collection for all of your products, or you could build different collections for different types of products, a collection for shirts, a collection for mugs, etc. Each item in a collection, represented by a markdown file, would have its own metadata and be associated with its collection. When the Wax team went about trying to solve issues in digital humanities, they saw a need for a new way to spin up simple digital exhibits that fit well with the minimal computing philosophy. By selecting Jekyll as the base platform for Wax, the team took advantage of an existing framework with useful features, including features for storing objects, displaying objects, and keeping with the minimal computing philosophy. When storing objects for a digital exhibit, Jekyll collections are a great fit. Each exhibit can become a collection, and exhibit items become collection objects. Jekyll handles the item metadata, and keeping the items in a collection makes other functionality much easier. When displaying objects, for example, Jekyll collections make it easy to iterate over exhibit items to pull all of them into a single page display. Instead of having to hard-code in every single item separately, Jekyll makes it trivial to write loops over all collection items. Finally, Jekyll itself fits nicely with the minimal computing philosophy. It's a platform that has basic features, is easy to learn, is well maintained by an active community, and is well integrated with a free web hosting platform, namely GitHub Pages. Jekyll out of the box is a very general website builder, so Wax extends Jekyll's capabilities to tailor it for digital exhibits. One way Wax extends Jekyll is by helping to prepare digital exhibit assets for the Jekyll way of building websites. Wax has 3 preparation steps it undertakes to get your exhibit files ready for Jekyll. The first step is to process the raw images of items in the exhibit. Wax can produce either simple thumbnails of the images or create IIIF derivatives for a more advanced display of the item. The second step is to generate item pages. Jekyll requires that each collection object has its own markdown file, but for large exhibits, creating pages individually can be very tedious. Instead, exhibit creators can build a single spreadsheet of exhibit item metadata, and Wax will process that file into individual markdown files for Jekyll. The final step is to add search functionality to Jekyll. Jekyll doesn't have a native search feature, so Wax includes its own search functionality, as well as a simple processing step that prepares the exhibit item metadata for the search. Wax supports these 3 preparation steps by using something called rake tasks. Rake works in Ruby to automate tasks. Let's look a bit more closely at how Wax processes and generates exhibit files using these tasks. The rake tasks used by Wax to process exhibit files basically pull from and write to the Jekyll site source files. In this slide and the next few slides, we'll explore each task to see what the inputs and outputs are. The first Wax data processing step is image processing. For image processing, you first store the raw images in a special directory named _data, inside a subfolder named for the collection. You will also update the Jekyll configuration file by adding the name of the image directory, as well as other defaults for the collection, like the default layout. You use the command line to run one of the Wax rake tasks for image processing, either the simple version or the IIIF derivatives version. The rake task will look for the raw images based on the specifications in the configuration file. It then generates the requested image derivatives and stores them in a custom directory called img. Finally, it updates your metadata file to include the paths to the image derivatives and additional helpful information such as the collection name and the default layout from the configuration file. The second Wax task is to generate item pages. Wax does this by finding the name of the metadata file in the configuration file, pulling the metadata for each item out of that file, and converting it into individual markdown files for each item. The metadata fields and values are included in the file's header section called a YAML or YAML header. The markdown files are now ready for Jekyll to build a collection out of the items. The third Wax task is to support Wax's added search functionality. This task looks for search properties in the configuration file, pulls in the metadata from all of the new item markdown files, and outputs a single file with all of the searchable metadata fields and values across all collection items. This file gets stored in a custom search directory that is then used by Wax-created pages in the final Jekyll site. Jekyll creates a website from a series of pages, templates, and configuration settings. After the Wax tasks have been run, the collection content is now ready for Jekyll, but the content needs special kinds of pages to show off the collection items and provide useful functionality. One type of page that comes included with the Wax repository is a browse page. A page that allows someone to browse all exhibit items at once, seeing a grid of thumbnail images. The Wax repository includes an example browse page, which specifies a particular sample collection. This page calls something called an include, which is a kind of template that can be designed to take a few parameters so it can be reused in multiple places across a website. The gallery include takes the name of the collection and the name of a metadata field. It then sets up the thumbnail gallery for each item in the collection and adds a filter at the top of the page based on the metadata field specified. Another type of page that comes included with the Wax repository is an item page. To be more accurate, the Wax page task already created our item pages, but Wax offers a special layout to help with the design of the item pages. In Jekyll, a layout determines how the header and content sections of a markdown file get converted into a web page. The Wax repository includes a layout called generic collection item, and this can be added to the configuration file as the default layout for a collection's item pages. The layout sets up an image viewer at the top and a table of metadata fields and values at the bottom of the page. But what does it really take to get Wax up and running? First, you will download the files from the Wax demonstration repository on GitHub. Next, you'll start replacing the demo exhibit files with your own files, including your metadata file and raw images. You will edit your configuration file to change the collection, search, and site information to match your project. At this point, you can run the Wax tasks to process your images and metadata and create the search index. Finally, you can edit the remaining pages to replace the Wax demo page content with your own. Finally, you will take your files and create a GitHub repository for them, setting up the GitHub Pages functionality to have GitHub build and host the site for you. To show you an example of what you can do with Wax, we'll dive into a project called Teaching Viz by Example, which uses Wax to build a repository of visualization and dataset examples for instructional purposes. This project was made possible in part by a National Forum grant from the Institute of Museum and Library Services. Searching for example visualizations or datasets that are appropriate for teaching, especially for short-form library instruction, can take a lot of time. Furthermore, existing places where data are shared do not necessarily capture the information that would be useful to evaluate the visualization or dataset. We saw a need for a repository really tailored to sharing and finding datasets and visualizations designed for teaching. Wax, while designed for digital exhibits, has many of the features we were looking for in a repository designed for highly visual content. We felt the minimal computing philosophy was an excellent fit for our project, situated as it is in libraries. We knew we would need something easy to deploy and maintain to promote sustainability. We felt that GitHub would be an ideal hosting platform, both for the ability to share code and for the ability to host without any fees. And finally, as a team, we were open to tools that would require light programming and command line processing. While Wax gave us a great starting point, we found a few features requested by our stakeholders were not already supported in Wax. First, we wanted to support metadata fields that would naturally contain lists, like visualization types or data types. We used custom scripts to produce a metadata file that preserves the lists during the Wax page creation task. The default Wax gallery offers a filter restricted to a single option from a single field. We have built a new page template that offers checkbox filters for multiple fields. We recognize that data documentation is not only best practice, but can also improve the design of a site. We have added a data dictionary that works with our pages to improve field labels and formatting. Finally, because items in our collection can relate directly to each other, we have created a custom field type that allows items to link to an arbitrary number of other related items. Our GitHub repository, linked at the end of our slide deck, includes the code for all of these features. We have compiled a list of resources that may be helpful to learn more about Wax and Jekyll. Please see the shared copy of our slides to access these and other links included in this presentation. This concludes our short tutorial on using Wax and Jekyll to build minimal digital projects. Please reach out if you have any questions or suggestions. Thank you.